June 2012, Core 1, Question 4, our differentiation question, optimizing question. First thing, we're being asked to find the surface area of this thing, so let's look at each of these sides in turn. The front here is 3x times y, so that's 3xy, and of course on the reverse there'll be another 3xy there. This side here is x times y, so you've got an xy and another xy on the other side there. And then at the top, we've got 3x times x, which is 3x squared. And on the bottom, there's another 3x squared. So what have we got all together? We've got 6x squared, and we've got 3, 6, 7, 8 xy's. And it says that the surface area is equal to 32. So let's write equals 32. I see a factor of 2 there, so let's divide everything by 2. And oh, look, that's what we were trying to get. 2 marks. Now we're going to find out the volume of the thing. And the volume of a cuboid is going to be the base times the width times the height. So I've got 3x times by x times by y. That means I need to know what y is. And I get y from this one here. By rearranging this, taking the 3x squared from both sides, I can get y all on its own. And then I can take this and drop it into my formula here. So v equals, well, 3 times x is 3x squared times by this thing that we've got here. We don't even need to do much multiplying out here, do we? Look, because that x can cancel with the squared. And so we're going to leave us with, well, 3x times 16, that's 48x over 4, minus 3 times 3, which is 9, x times x squared is x cubed over 4. Last thing to do is to cancel this one down, is that that's just 12x minus 9x cubed over 4, just like we were asked to get. Now it asks us to differentiate it, and so differentiating the first thing, no trouble at all. The x just disappears, doesn't it? Powers go down by 1. Next one, some people mucking up their fractions here, though. Let's see if we can do this. So we're going to times by the power. Times by the power. So 9 times 3 is just 27. And the power goes down by 1. There. So if we just cope like that, don't get stressed with the fractions. Find out, verify. Verify, there's that word again. We've had it in the last few ones. It means we're going to need to leave a final statement. But we're going to put 4/3 into this thing here. So we're trying to do, so this is dv by dx equals 12, take away 27 over 4, times by 4 over 3 all squared. Notice I've just rewritten that in a different way. Here's the fraction, 27 over 4, and I'm putting that in there. So I've got 27 over 4. Now squaring this means I've got 16, 4 times 4 is 16, over 3 times 3 is 9. And now we can just do some cancelling. 4's into that go 1, 4's into that go 4, 9's into that go 1, 9's into that go 3. So I've got 12 take away 12 equals 0. And because it equals 0, therefore this point is a stationary point. Final statement needed. Perhaps even more than that. Therefore there's a stationary point when x equals 4 over 3. Now we're going to differentiate yet again. So let's do d2v by dx squared. The 12 now totally disappears. We've now got this minus. Don't forget that minus there. And we're timesing by the power. So timesing by 2. 27 times by 2 is 54. 54 over 4. And the power goes down by 1x. I mean, that does cancel down, but let's just leave it like that for now. Now, when x equals 4 over 3, what does this equal? d2v by dx squared equals, we got minus 54 over 4 times by 4 over 3. They cancel. So I've got minus 54 divided by 3, Well, we could just leave it like that, couldn't we? The only important thing is that it's negative. So we now write negative, therefore it's a maximum point. So if it's negative, it's a maximum. If it's positive, it's a minimum. Here is the mark scheme. Here is the examiner's report. A bit small, sorry, just pause it